Hello and welcome to another video. In this one, we're going to talk about how I made pip, the Python package manager, 25% faster to start up, which I guess it saves about 150 milliseconds every time you run pip, which isn't much, but it adds up given basically everyone that runs Python uses pip. Anyway, let me show you how I did that. Okay, so this is the actual PR. The PR itself is not that interesting. We actually have to dive deep down a rabbit hole to figure out the actual reason that I was able to improve this. But just to show you, I wrote a tiny little script that does a best of 10 or best of however many I wanted and shows how slow the command was. And I was just using pip-help here, which doesn't really do anything other than show the output of pip. As you can see, before my patch, it was about 570 milliseconds, and then after, it was about 430 milliseconds. A nice 140 millisecond improvement, which corresponds to about 25%. And all I really did in this patch here is upgrade PyParsing, and in order to understand the improvements that I made here, we have to look at the patch I made to PyParsing. We're not going to quite look at that just yet. We need to first look at the issue. So this is the rabbit hole. This is where I originally started. And actually, if I unwind the rabbit hole, the reason I noticed this at all was I was upgrading pip and I noticed that pip felt a lot slower between two different versions. The 150 millisecond pause was noticeable. So I started with trying to figure out why it was slow. Did a little bit of profiling, and I noticed that PyParsing was significantly slower in 300 versus 247. Let me just show you that. PyParsing. Let's just make a virtual env and pip install editable dot, and we're going to git checkout 2.4.7 v. Hit some sort of non-standard tagging. Okay. I will judge, but I won't judge. And if we do time python 3-c import PyParsing, we get some idea of the time here. It's taking about 50 milliseconds on 247. If I check out PyParsing 300 and run the same thing again, you'll see that it's way slower, about 100 milliseconds slower. And so I wanted to figure out what made it slower. And first I did a little bit of profiling here. You can see this is basically the same thing that I just showed you here. I did a little bit of profiling and noticed that, if we zoom in on this a little bit, that most of the time is spent in regex compilation. Almost 80% of the startup of importing PyParsing was spent compiling regular expressions. And I had some initial ideas here that, like, well, maybe it started compiling a bunch more regular expressions, or maybe they got more complicated. And I started thinking of ideas on how to fix that, like deferring the compiles or doing stuff like that. But I'm jumping a little bit ahead here. But I did a little profiling. Notice regex compiling was the dominant part of the new startup. So I thought that, okay, maybe that's why. I wanted to know if there were any regressions, so I wrote a little script to try and bisect this. And the way I did this is basically a cutoff for how slow it was. So you can see here, like, this is 50 milliseconds, so we could reliably set a cutoff above that. Let's show you this little script here. Basically, I made it profile a certain number of times. I set a cutoff so that it would error if it was above that. And then I ran subprocesses to time the import of this. And this is kind of a little best of mini profiling thing. It's not super scientific profiling, but it is a nice way to figure out how slow something might be, and return non-zero if it fails that. I made this little script here. Did get bisect start, yeah, get bisect good, PyParsing 247, git bisect bad, PyParsing 300, and then git bisect run python 3 t.py. And what was the options there? We'll just leave best of at 5, and we'll set the cutoff at, what did I do the cutoff here? I did a 90 millisecond threshold and 120 millisecond threshold. Let's say 90.09. That'll be 90 milliseconds, I think. Yeah, something like that. And so then this will just run a bunch of times. Oh, we had an error in the middle. What was this? ABC meta is not subscriptable. Okay. Shoot. I guess I have to use a newer version of Python. Wait, I could have sworn I was able to bisect this before. Ugh. Maybe we need to use a newer version of Python. Let's do Python 3.10. Okay. Start. Bad. Good. Run. That seems to be working a little bit better. Okay, so we get our first identified regression here. Add URL expression to PyParsing comment. So let's take a look at this commit. I can show you why it got a lot slower. Is it perhaps this giant regex? I don't think it actually is that regex. It's something else. Oh no, it's definitely that regex. So this regex has significant complexity, pretty big regex, and apparently this is enough to increase the timeout enough. So you can see here, the bisect had like 50 to 60 milliseconds, and then 100 milliseconds. That was kind of our tipping point there. That's one of the things that made it slower. And then if we show the other one, start, good, bad, and then run. But this time we're gonna do a cutoff at 120 milliseconds, which will get us our second regression. I did this all in stream at twitch.tv/AnthonyWritesCode. So, oh dang, we got another problem in here. Hopefully that doesn't matter here. Yeah, it doesn't actually matter. Okay, so ignore this. There is actually a way in Bisect to ignore crashes by using a special exit code. I didn't bother here because it was super important. But let's take a look at this commit as well and see why this one made it slower. And spoilers, it's also regular expressions. So this is a regex here, HTML entity map, which used to map a certain number of HTML entities, greater than, less than, ampersand, non-breaking space, a quote, and an apostrophe. Just a few HTML entities. And so this regular expression wasn't terribly complicated, but it was switched to use html.entities.html5.items. We take a look at this. It went from being, let's see, 1, 2, 3, 4, 5. It went from being 6 entities to being html.entity. len html.entities.html5. It went from being 6 to 2,231 entities. So this pattern exploded in size, and that was why it got significantly slower. All right, cool. So we've identified the 2 ways it got slower. Let's talk about how I made it faster. And again, my ideas here were to lazily construct the regular expression. That way we're not compiling this giant pattern for every user, because I don't think most users really care about HTML entities. I mean, maybe they do, but we shouldn't penalize every user of PyParsing just based on this. My thought was to make this regex object a little bit lazy, to not eagerly compile this pattern and maybe defer it until later. That way it isn't an import cost. It's potentially a little bit of a runtime cost if you use it, but it's not gonna punish everyone. And so that was kind of my thoughts here. Or to use something more advanced like module level git adder for Python 3.7 plus, or other ways to do this as well. And had a little back and forth with the maintainer to kind of have some ideas here. I also profiled every commit in addition because the maintainer wasn't super sure about whether those were responsible for it, and hopefully this convinced them. Oh, this was this was that commit that's broken. That's why it's there. But you can kind of see here, I profiled every single mainline commit to get an idea when things got slower or faster. You can see here that this is our right around here. This is merges, right? Merges are going to be annoying. Can't actually see super well when the change was. That's frustrating. Maybe we'll see it further back. I don't know. But anyway, I profiled every commit and basically showed that those were the ones that increased the value significantly. from that I was able to show the change here. Yeah, actually, here we go. This is the one bump there, and then the other bump is right here. Common HTML entity. And so with that in mind, I took my idea to lazily compile the regular expressions and modified the regex class in PyParsing to, well, I had to backport cache property first off, to lazily compile this regex object, self._re. So you can see here, this is what it was doing before. It was eagerly compiling this regular expression. So I changed it to lazily compile it and hide it behind a cache property. So still the same code, but now only when you access this regular expression does it produce, or does it actually do the compilation. I also had to cache these as well. These are some derived properties based on the regular expression, so these are deferred as well. And cache property is nice in that it only has overhead on the first call, and then after that, it's essentially just a normal attribute lookup for the value, which is pretty cool. But anyway, made those changes, and I didn't quite get it back to the original speed of PyParsing 247, so there's potentially more improvements to be made here. But I got it, 100 milliseconds down, which I think is pretty worth it. 100 plus milliseconds. But yeah, basically made that change. It made its way into the latest version of PyParsing, which I believe is 308 or 309. I don't know, something like that. And then I upgraded pip, or I upgraded the vendored version of PyParsing in pip, and that's how I got the speed up there. So hopefully you saw a couple of cool things here, using profiling tools to bisect a performance regression, some ideas about regular expressions and how this change doesn't look that scary, but when you have 2,000 entities, those add up pretty quickly as well. Just kind of a neat little fix here. Anyway, hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.